And just like that, we made it. This is episode 7 of our 7-part series, the finale. We are finishing this, and then we're going to get Jared back on the podcast. This is episode 97. And in this episode, we're going to conclude our series on what raises and lowers specific chemistries in a swimming pool. This last one is about phosphates. Now, we talk about phosphates in more detail in episodes 23, 25, 26, 38, 59, 64, 71, and 76. Just know ahead of time, if you didn't already know, of all of the things we've talked about, this 7th one is something we actually make a product to address. When we're talking about pH and alkalinity and calcium, all of that is general chemistry. This one is really a specialty for us. So, with that, episode 7 of 7, let's finish this.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
So what are phosphates? Well, as we've discussed in previous episodes, and we write extensively in our blog, and Pillar 3 of our 4 Pillars program, phosphates are just forms of phosphorus that are found in water. And the building block of these phosphate compounds are called orthophosphates, PO4. So for example, if you have condensed phosphates, meaning a compound of phosphates, you will have something like metaphosphates, which are a bunch of orthophosphates structured in a ring. And then you have polyphosphates, which are more of a chain. And I'm sure there's others, but we're going to focus on those two because in swimming pools, the way that we get phosphates in water, which we're about to discuss, is usually going to be in those two forms. The trick here is phosphate test kits typically only measure the building blocks. They only measure the PO4, the orthophosphates. So if you have a phosphate compound from, say, a sequestering agent or something, there's a chance that that test kit may not be able to read it yet. Not until it breaks down into its building blocks and that test kit can recognize it. This is actually a very common thing that we see. People will test and say, oh, I've got 1,200 parts per billion phosphate. And then they remove, based on our dosing chart, 1,200 parts per billion, but they still have more. Yeah, well, the reason that happens is you probably had a lot more than 1,200, but your test kit only showed 1,200. See, you could have had stuff in other forms, especially if you're using products that are in condensed compounds. So, what causes phosphates to increase? They are introduced to your water primarily 3 ways: chemically, environmentally, and through your tap water. So we'll start with chemically. Sequestering agents are almost always phosphate-based. Phosphoric acid, phosphonic acid, some combination therein. We don't know specifically what is in every sequestering agent in the industry, but we do know that most of them are phosphate-based in some way. And that's not a knock on the products, by the way. They work. They work really well. The challenge is they are basically liquid phosphates. So at some point, they become a problem for your pool, and you just need to be aware of that. Because if you put in a phosphate remover, like PR10000, you're going to wipe out that sequestering agent. We see this all the time. This is why we don't make a sequestering agent in our line. One of the 3 tenets of our philosophy is no chemical conflicts. Why on earth would we sell you something that another product we make is going to wipe out? That's a conflict, so we don't do it. There are no phosphates in SC1000, so there's no conflict between PR and SC. That's by design. So be aware of that if you're putting in a sequestering agent, you are putting phosphates into your pool if it's phosphate-based. So that's the first thing. There are other ways that you can get phosphates in without even putting sequestering agents in. For instance, a lot of cal-hypo tabs have scale inhibitors in them. They're blended into the tab. So you actually have phosphates in the tab. So your phosphates will go up over time. It's meant for scale inhibiting so that you don't scale up your cal-hypo feeder as fast. Good in theory, but phosphates climb. And then there are also specialty acid products that are buffered with something like phosphonic acid to make it less fuming. Now, I'm bringing this up because I know it used to be this way, but from what I've heard, some of these products have changed their formulas to remove phosphates. I remember going to a commercial pool many years ago, We could not figure it out. We tested the tap for phosphates, nothing. There were no sequestering agents being used, nothing. The only thing in there that I didn't recognize was a specialty acid product. And sure enough, it said it right on the SDS sheet. I looked up the label, pulled out my phone, looked up the SDS sheet, boom, phosphonic acid. Well, there was your answer. And these phosphates in the pool were through the roof because they were feeding acid on a feeder all the time. That's kind of a Trojan horse of how you can sneak phosphates in, whether it's in your cal-hypo tabs or your specialty acids. It doesn't always have to be a sequestering agent, although a sequestering agent is definitely going to be the number one culprit for putting phosphates in chemically. Which brings us to our next one, tap water. Now, when I originally listed this, I have it on my show notes here, chemically, environmentally, and tap water. But tap water is more related to chemically because ever since the Flint, Michigan water crisis, all the lead poisoning and all that stuff, municipalities around the country started putting phosphates in their water. That's not to say that they weren't doing that before, some were, but now it's widespread because putting phosphate compounds in water to sequester metals and to protect the pipes from corrosion and even scale is a very common practice now. Here's the thing, orthophosphates are not harmful for us. They're good for our bodies, they're good for our drinking water, they're good for our lawns, they're good for your dog. Everything is a benefit until the phosphates get into your swimming pool. So if you're on city water, you can bet there's probably some amount of phosphate in your water. Some places put phosphate sequestering agents in them. Others literally put orthophosphates directly in them. So it just depends on where you are. The levels are very different. I live in Charlotte, North Carolina. The levels here are over 1,000 parts per billion out of the tap. I've tested tap water. Go the extra test and get a phosphate reading just for curiosity's sake. See what you're up against. See what you're dealing with. There's a really good chance that you're going to have phosphates out of that city water. But it's not just city water. It's going to be well water too. Because well water is groundwater. Think of what water has to do to get down into the water table. You have rain percolating through soils, which are loaded with phosphorus, nitrogen, all this stuff. You're inevitably going to have some phosphate in that water. But the levels depend on where you are, the type of soil you have, how deep is your water table, all sorts of factors. I will say this, if you go back 20 years, and we know this because we've talked to industry veterans who have been doing this a long time, phosphates were not even a conversation. And that's because they weren't in tap water very often. That's the big difference. Oh, phosphates, what's the big deal? There are sources online that say phosphates don't matter. Just have enough chlorine in your water and it won't matter. You could have enough chlorine to deal with it, but chlorine cannot oxidize phosphates. So why not be more efficient and decide to take phosphates out of the equation? Every brand has a phosphate remover now, it seems. There's a reason. They work. They make a huge difference on water quality and chlorine demand. If you're trying to be more efficient and manage cleaner, clearer water, removing phosphates is a good thing. That's why it's our third pillar of proactive pool care. The final one is environmentally. What is around the pool that could get into it? Well, bathers. We track things in. We have phosphates in our cells, dead skin cells, dirt on our feet, soils that get into the pool, grass clippings, decaying leaves, pine needles, acorns, fertilizers. All these things that break down contain some phosphate. Dead leaves and grass clippings, they also contain tannins. They also contain nitrogen to some degree. So decaying organics in general, you want to keep cleaning them out because they continue to put in more oxidant demand into your pool. But phosphates are not part of the oxidant demand because phosphates cannot be oxidized. This is why you cannot just rely on chlorine to get them out. Chlorine doesn't interact directly with phosphates. And that brings us to how to remove phosphates. I need a pause here because if you've been listening to this 7-part series, I messed up earlier because I forgot about reverse osmosis filtration, RO. My apologies to those of you who have used RO and to those of you who have RO trucks. Kudos to you. It's a great system, so I'm going to give it its due right now. Here's the thing. RO filtration is not as common in areas that have plenty of rain and no water restrictions. But when you go out west and you are in the desert and areas that have strict water restrictions and droughts, reverse osmosis might be a really good solution for you. It not only removes calcium, TDS, salt, cyanuric acid, but it also removes combined chlorine. It also removes phosphates. It's basically resetting your water. The level of filtration is insane. And what you can do is you can bring one of these trailers and park it in your driveway overnight, and they will basically cycle your pool through this filtration. And it is very effective. Unfortunately, it's not like water's waiting its turn to get pulled through, so you may not get all of it out. But if you're trying to reduce it, RO filtration is an extremely efficient way of doing that. So I'm just going to say that first, even though it's not the top choice for, there's way easier ways, more affordable ways to remove phosphates. I just need to give RO its due because it is an awesome technology, but just understand it takes everything out too. It's not like you can just target it for phosphates or just calcium or just CYA. No, it's a nuclear option, so to speak. So that's the first way. Reverse osmosis will remove phosphates and everything else. Now, the second way, and not a very effective way, I might add, is dilution. Now, this doesn't really work with tap water because, as we said earlier, tap water is usually going to have phosphates in it. So depending on where you are, it's kind of silly to rely on dilution to remove something that you're just putting back in, depending on the levels in your tap. What is effective is rain and snow dilution. Because rain and snow come from the sky, they do not have any phosphates in them. The main way to remove phosphates, of course, is with a phosphate remover. We make one. In fact, we actually make two. Our main one is called PR10000, but we also blend a different type of phosphate remover into our enzyme CV700. Two different products, but they both remove phosphates. Phosphate removers work by pulling phosphorus out of solution by solidifying it into a solid. It's usually a fine white dust, and in that process, when you take something out of solution and turn it into a fine white dust, that clouds the water because you're seeing the dust. That's an inevitable part of this process. Then you just have to deal with the dust. Now that dust is inert. It is harmless, but it cannot be reversed. You can't redissolve it. It's not like calcium carbonate or plaster dust. You can't just lower the pH and have it go back into solution. When phosphates are removed, they're removed. Now you just have to deal with the dust. Either vacuum it to waste or clean your filter out. Either way, it's out of solution. We make PR10000, but there are a lot of phosphate removers on the market that you can use to different strengths and dosing. So pay attention to the dosage and whatever works for you. We strongly recommend doing it regardless of whose product you're using, just because phosphates complicate things. They make chlorine more inefficient. They add to the chlorine demand indirectly, but you can learn more about that in Pillar 3 of our 4 Pillars program. We don't have time to go down that rabbit hole on this podcast. But we did do an episode on Pillar 3. I think it was episode 23. If you go back and listen to that, it'll give you a lot more context. So in summary, if you want to raise phosphates, it's pretty much happening automatically. So you're not ever going to try to raise phosphates. They're just going to happen. So don't deliberately try to raise phosphates. There's no real benefit to having more phosphates in your pool. In fact, the entire purpose is to get them out of your pool. You are dealt this hand of cards, try to remove them. Removing them is either done by reverse osmosis, just to give them credit because it is a cool technology, but that's not the most effective way to remove phosphates. The most effective way is to use a phosphate remover. It's that simple. This has been episode 97. Thank you for putting up with me. I hope that this has been valuable for you. In the next episode, I promise we're going to have Jared back on, and if our timing is right, it's going to be our Christmas episode. You all have been great. Thank you so much for the feedback. Thank you for emailing these questions to podcast@orendatech.com and for reaching out through our help center, ask.orendatech.com. Thank you for listening, and we hope to see you next time. Take care, everyone.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.